Welcome to Month 5 of the Tech Lead track. This session is Advanced Tech Leadership, Vision, Innovation, and Strategic Thinking. Over 4 hours, you will develop a technology vision for your team. Learn how to build a culture where engineers actually innovate rather than just talking about it. Create a team charter that people reference rather than file away. And learn how to present strategic technical decisions to executives in a way that earns investment rather than skepticism. The 4 hours are structured as follows. Hour 1 covers technology, vision, why tech leads need one, the 5P framework for building it, a workshop to draft your own, and strategies for communicating it to different audiences. Hour 2 is innovation culture, what psychological safety actually means in practice, the 70-20-10 framework for balancing innovation with delivery, and concrete innovation programs you can run with your team. Hour 3 is team charter, the 6 elements that make a charter useful, and a workshop to create one. Hour 4 is strategic leadership, investment frameworks, how to present strategy to executives, common tech lead pitfalls, and the offline milestones. 5 capabilities to build today. First, develop and articulate a technology vision, not a vague aspiration, but a specific, directional statement that gives your team a North Star for daily technical decisions. Second, build and sustain an innovation culture by creating the conditions for experimentation rather than mandating creativity. Third, create a team charter that the team actually references when there is friction or ambiguity. Fourth, balance innovation with delivery using a portfolio approach that protects commitments while creating space for exploration. And fifth, make strategic technology investments that you can defend to leadership with numbers, not opinions. Without a technology vision, 3 things happen. Decisions are reactive. Every technical choice is made in isolation with no North Star to align against. A team building distributed systems makes different choices than a team optimizing for simplicity, but only if they have agreed on which direction they are heading. Priorities are scattered. The team pulls in different directions because different engineers have different implicit ideas about what matters. And when something ambiguous comes up, a library choice, an API design, a database schema, everyone argues from first principles because there is no shared framework to resolve it. A technology vision does not prevent disagreement. It gives disagreements a frame. It answers the question, what are we optimizing for, before the specific decision arises. A technology vision has 5 components, all starting with P, purpose. Why does your technology matter to the business? What value does it create that could not exist otherwise? A weak purpose is, we build scalable software. A strong purpose is, our platform eliminates the 48-hour manual reconciliation that every finance team runs today. Principles. The guiding technical philosophy, what you will consistently choose when forced to trade off between 2 good options. Priorities. Where you will invest attention and budget, and what you will deliberately not invest in. Picture. The future state description. Specific enough that 2 engineers reading it independently would make the same architectural choice. And path, the sequence of decisions and milestones that gets you from today's state to the future picture. A good technology principle answers. What would we do when forced to choose? Each principle must include a trade-off you consciously accept, or it is not a principle, it is a wish. Developer experience first is a principle if it continues with, even if it slows initial implementation. Reliability over features is a principle if it continues with, we will cut scope before we cut testing. Principles that contain no trade-off collapse, under the first real decision that costs something. When drafting principles, test each one against a real recent decision your team made. If the principle would have led to a different outcome, and you stand behind the principle, you have found something to talk about. If the principle would have endorsed the decision you already made, it may be a rationalization rather than a guide. Innovation culture has 5 conditions, and only one of them is about having good ideas. The first is psychological safety. Engineers must feel safe to propose ideas, admit mistakes, and challenge assumptions without career risk. The second is time for exploration. If every engineer is fully committed to delivery, there is no capacity to experiment. The third is resource access, tools, budget for services, and access to production data for experimentation. The fourth is recognition, celebrating attempts, not just successes. A team that only rewards shipped features never experiments with anything that might fail. The fifth is leadership support. Visible, public backing from you as tech lead and from your manager. Innovation announced in a team meeting and then never mentioned again produces exactly 0 experiments. What you fund and what you protect from scope cuts is what the team believes you actually value. Psychological safety is not created by stating that it exists. It is created by specific, visible behaviors that signal to engineers what actually happens when they take risks. As tech lead, you celebrate thoughtful failures publicly, not just privately in one-on-ones. You never punish a good faith experiment that did not work out. You debrief it and extract the learning. When someone proposes an unconventional idea, you ask curious questions before expressing any skepticism. What would you test first? Is more useful than I'm not sure that would work. You admit your own uncertainty in public. I don't know the right answer here yet. Models the behavior you want from the team. And you never mock a question, however basic. The cost of mocking one question is every question that will never be asked in that room again. The 70-20-10 framework is a portfolio approach to how engineering capacity is allocated. 70% goes to delivery, current feature commitments, bug fixes, reliability work, and everything the business expects. This is the floor, not a ceiling. Protect it ruthlessly. If the business cannot trust the team to ship what it committed to, there will be no 20 or 10. 20% goes to growth experiments, new patterns, adjacent capabilities, performance optimizations that go beyond the current spec, internal tools that make the 70% faster. These should be connected to a near-term business outcome. 10% goes to exploration, foundational technology investigations, learning experiments, things that may pay off in 2 years or not at all. This is where career development and long-term differentiation come from. The split is a conversation starter, not a mandate. Some sprints are all delivery. Some weeks have slack that enables more exploration. The discipline is in ensuring that exploration does not crowd out commitments and delivery does not crowd out growth indefinitely. 3 programs that create consistent innovation activity. The first is weekly innovation time, 10% of each engineer's capacity, roughly 4 hours per week with no approval needed for the topic, and the only guardrail being a 5-minute share-out at the end. The share-out is what makes this work. It creates a lightweight accountability mechanism and surfaces what the team is curious about. The second is a quarterly hackathon, 2 days per quarter with cross-functional teams, a demo at the end, and real budget to ship promising results. Hackathons without a path to production train engineers that experiments are disposable. The third is an innovation backlog, a shared place to capture ideas that are too large for weekly time and too speculative for the roadmap. Review it quarterly and consciously choose what to invest in and what to archive. A team charter is a living agreement the team actively references when friction arises, not an onboarding document that lives in a wiki nobody reads after the first week. 6 elements. Mission and purpose. Why does this team exist? What would disappear from the world or the company if the team did not? Decision-making process. Who decides what, using which process? Ambiguity about this is the source of most team friction. Values and norms. What behaviors do we commit to? Communication protocols. When do we use synchronous versus asynchronous? What is the expected response time for different channels? Success metrics. How do we know we are doing our job well? And individual growth areas. What is each person working on developing? Making growth visible creates accountability and enables the team to route work that develops specific skills. Different types of technical decisions warrant different decision-making processes. Architectural decisions, the ones with broad consequences and hard-to-reverse outcomes, should involve the tech lead and the team through a request for comments process with an open comment period. Daily technical decisions belong to individual engineers to make autonomously, with the norm of informing the team asynchronously. Cross-team or cross-functional decisions need a collaborative process with explicit stakeholder input. Emergency production decisions are made by whoever is on call, with a post-incident review to determine whether a policy change is needed. The failure mode to avoid is applying the same process to every decision. Using RFC for daily choices creates decision paralysis, while making architectural decisions unilaterally creates alignment debt that surfaces later as unexpected disagreement. Every request for strategic investment in technology follows the same narrative structure. Here is the problem with the current state. Here is what the target state looks like. Here is the cost and the measurable return on investment. 3 examples from a team in a growth phase. Platform reliability. Current state is 97.5% availability. Target state is 99.9%. The investment is 4 weeks of engineering time. The return is reduced customer churn from SLA breaches, quantified at a specific dollar amount per breach avoided. Developer productivity. Current state is 3 weeks from feature idea to production. Target is 3 days. The investment is in automated testing infrastructure and deployment tooling. The return is more features shipped per engineer per quarter, measurable. Technical debt reduction. Current state has 30% of engineering time going to firefighting and maintenance. Target is 10%. The investment is a dedicated refactoring sprint each quarter. The return is 20% more capacity for feature delivery. Notice that each framing leads with the problem, not the solution, and each outcome is a number, not an adjective. When presenting a technical strategy to executives, the structure is inverted from how engineers think. Start with the executive summary, 3 key messages, what you need from them, and why it matters. Executives decide in the first 90 seconds. If you have not earned their attention by the end of slide 1, you will not get it back. Second, show the current state with data. What is working? What is at risk? And the specific cost or opportunity attached to each. Third, present the proposed direction. What changes, what does not, and what the first step is. Fourth, state the investment required, time, money, headcount, and the expected return in the same unit's leadership tracks. Fifth, show that you have considered the risks and have a mitigation plan. Executives who have seen many initiatives fail are not skeptical about technology. They are skeptical about plans that do not account for what could go wrong. Acknowledge the real risks and explain how you manage them. 4 traps that catch tech leads who are otherwise technically excellent. The first is a vision too abstract. Be world-class engineers tells no one what to build next Monday. Abstraction without specificity produces paralysis. The second is innovation without business alignment. A 20% innovation program that generates 0 shipped results for 2 quarters will be canceled. Every experiment should have a plausible connection to a real business outcome, even if that connection is indirect. The third is an all vision, no execution problem. Spending all your time on strategy and vision while the team's daily work drifts. Vision without follow-through teaches the team that strategy is theoretical. The fourth is context switching that undermines depth. Tech leads who are in 5 different meetings before lunch and have no protected time for technical work lose their credibility as technical leads faster than they realize. Protect at least 2 to 3 hours per day for technical depth, or you will be giving technical opinions from an increasingly outdated mental model. The Month 5 Challenge puts you in the role of tech lead for a team of 8 engineers, growing to 15, building a customer-facing platform at a rapidly scaling company. The team needs foundational leadership infrastructure, a technology vision, an innovation program, and a team charter before the hiring wave hits and the team's culture is set by whoever happens to join in what order. 3 deliverables at 25 points each. A technology vision document using the 5P framework. An innovation culture framework that specifies which programs you will run and how you will measure their success. A team charter covering all 6 elements. You have the company context in the challenge brief. Read it before you start so that the deliverables are grounded in the specific situation, rather than generic templates. 5 milestones before month 6. Draft a technology vision for your actual team, not the training scenario, and share it with the team to get 1 round of feedback. Implement 1 innovation time program and run it for 4 weeks, tracking what engineers actually work on. Create a team charter collaboratively, not as a solo exercise. Run 1 70-20-10 planning discussion in your next sprint, planning and document how the split ended up. And read Will Larson's Staff Engineer, specifically the strategy section. It is the most rigorous treatment of how to think about technology strategy at the team and organization level. Assessment. Each deliverable is scored on clarity, specificity, and usefulness. A vision that is too generic to guide a decision scores lower than one that is opinionated, even if imperfect. 3 ideas to carry out of this session. Vision creates alignment without constant direction. Once the team has internalized the vision, you do not need to be in every decision. Safety is a prerequisite for innovation, not a bonus. Without it, the 10% exploration time produces nothing. Because no one will take a risk on something that might fail publicly, and strategy is visible through the decisions you protect, not the documents you write. What you are willing to cut and what you are not willing to cut tells the team more about your priorities than any vision document. That is the work of an advanced tech lead. See you in month 6.